In chemical physics and physical chemistry, chemical affinity is the electronic property by which dissimilar chemical species are capable of forming chemical compounds. Chemical affinity can also refer to the tendency of an atom or compound to combine by chemical reaction with atoms or compounds of unlike composition. History. Early theories. The idea of affinity is extremely old. Many attempts have been made at identifying its origins. The majority of such attempts, however, except in a general manner, end in futility since affinities lie at the basis of all magic, thereby predating science. Physical chemistry, however, was one of the first branches of science to study and formulate a theory of affinity. The name affinitas was first used in the sense of chemical relation by German philosopher Albertus Magnus near the year 1250. Later, those as Robert Boyle, John Mayow, Johann Glauber, Isaac Newton, and Georg Stahl put forward ideas on elective affinity in attempts to explain how heat is evolved during combustion reactions. The term affinity has been used figuratively since c. 1600 in discussions of structural relationships in chemistry, philology, etc., and reference to natural attraction is from 1616. Chemical affinity, historically, has referred to the force that causes chemical reactions, as well as, more generally, and earlier, the tendency to combine of any pair of substances. The broad definition, used generally throughout history, is that chemical affinity is that whereby substances enter into or resist decomposition. The modern term chemical affinity is a somewhat modified variation of its 18th century precursor, elective affinity, or elective attractions, a term that was used by the 18th century chemistry lecturer William Cullen. Whether Cullen coined the phrase is not clear, but his usage seems to predate most others, although it rapidly became widespread across Europe, and was used in particular by the Swedish chemist Torbjörn Olof Bergman throughout his book De Attraction och Selektivitet, 1775. Affinity theories were used in one way or another by most chemists from around the middle of the 18th century into the 19th century to explain and organize the different combinations into which substances could enter and from which they could be retrieved. Antoine Lavoisier, in his famed 1789 Traité élémentaire de chimie, Elements of Chemistry, refers to Bergman's work and discusses the concept of elective affinities or attractions. According to chemistry historian Henry Lester, the influential 1923 textbook Thermodynamics and the Free Energy of Chemical Reactions by Gilbert N. Lewis and Merle Randall led to the replacement of the term affinity by the term free energy in much of the English-speaking world. According to Prigogine, the term was introduced and developed by Théophile de Donder. Goethe used the concept in his novel Elective Affinities, 1809. Visual representations. The affinity concept was very closely linked to the visual representation of substances on a table. The first ever affinity table, which was based on displacement reactions, was published in 1718 by the French chemist Étienne François Geoffroy. Geoffroy's name is best known in connection with these tables of affinities, tables des rapports, which were first presented to the French Academy of Sciences in 1718 and 1720, as shown below. During the 18th century, many versions of the table were proposed, with leading chemists like Torbjörn Bergman in Sweden and Joseph Black in Scotland adapting it to accommodate new chemical discoveries. All the tables were essentially lists prepared by collating observations on the actions of substances one upon another, showing the varying degrees of affinity exhibited by analogous bodies for different reagents. Crucially, the table was the central graphic tool used to teach chemistry to students, and its visual arrangement was often combined with other kinds diagrams. Joseph Black, for example, used the table in combination with chiastic and circlet diagrams to visualize the core principles of chemical affinity. Affinity tables were used throughout Europe until the early 19th century, when they were displaced by affinity concepts introduced by Claude Berthollet. Modern conceptions in chemical physics and physical chemistry. Chemical affinity is the electronic property by which dissimilar chemical species are capable of forming chemical compounds. Chemical affinity can also refer to the tendency of an atom or compound to combine by chemical reaction with atoms or compounds of unlike composition. In modern terms, we relate affinity to the phenomenon whereby certain atoms or molecules have the tendency to aggregate or bond. For example, in the 1919 book Chemistry of Human Life, physician George W. Carey states that health depends on a proper amount of iron phosphate Fe3, PO4, 2 in the blood, for the molecules of this salt have chemical affinity for oxygen and carry it to all parts of the organism. In this antiquated context, chemical affinity is sometimes found synonymous with the term magnetic attraction. Many writings, up until about 1925, also refer to a law of chemical affinity. Ilya Prigogine summarized the concept of affinity, saying, "All chemical reactions drive the system to a state of equilibrium in which the affinities of the reactions vanish." Quote, Thermodynamics. The present IUPAC definition is that affinity A is the negative partial derivative of Gibbs free energy G with respect to extent of reaction shear constant pressure and temperature. That is, A equals minus G she P T display style A equals left frac partial G partial she right underscore P T closing curly bracket. It follows that affinity is positive for spontaneous reactions. In 1923, the Belgian mathematician and physicist Théophile de Donde derived a relation between affinity and the Gibbs free energy of a chemical reaction. Through a series of derivations, de Donde showed that if we consider a mixture of chemical species with the possibility of chemical reaction, it can be proven that the following relation holds. A equals minus delta R G display style A equals delta underscore R G backslash closing curly bracket. With the writings of Théophile de Donde as precedent, Ilya Prigogine and Defay in Chemical Thermodynamics, 1954, defined chemical affinity as the rate of change of the uncompensated heat of reaction Q as the reaction progress variable. A reaction extent she grows infinitesimally. A equals D Q single quote D she display style A equals frac mathroom D Q mathroom D she backslash closing curly bracket. This definition is useful for quantifying the factors responsible both for the state of equilibrium systems, where A equals 0, and for changes of state of non-equilibrium systems, where A does not equal 0. See also chemistry, chemical reaction, chemical bond, electronegativity, electron affinity. Etienne François Geoffroy's 1718 affinity table, valency, affinity chromatography, affinity electrophoresis. Notes. This article incorporates text from a publication now in the public domain. Chisholm, Hugh, ed. 1911. Affinity. Chemical. Encyclopaedia Britannica. 11th ed. Cambridge University Press. William Whewell. Establishment and Development of the Idea of Chemical Affinity. History of Scientific Ideas. 2. 15 ff. Chemical Affinity and Absolute Zero 1920 Nobel Prize in Chemistry Presentation Speech by Gerard de Geer, Elements, Principles and the Narrative of Affinity. Essay review.